Smart home automation using two-way switching. ESP32 pinout reference, which GPIO pins should you use? ESP8266 pinout reference GPIO's pins guide. Abstract. Our smart home automation provides a low cost-effective and flexible home control and monitoring system using QR code. As home automation has become more and more commercial and marketable in recent years, the goal of our project is to provide comfort to old and disabled people, as scanning of QR code is a one-time process and can be accessed by anyone easily. Our proposed system required ESP32 and ESP8266 microcontroller to provide wireless connections to electrical appliances. We introduce smartphone application, as smartphones are commonly used nowadays, and our application provides easy access to our home by using Wi-Fi module, Bluetooth, scanning of QR code. The wastage of electricity can be known by notification on smartphone application. Application can be logged in by using QR code or SSID. Keywords: QR code, SSID, two-way switching smartphone application. 1. Introduction. 1.1 Overview. Classic smart home, Internet of Things and using QR codes for security are the building blocks of our proposed advanced home automation. Each component contributes its core attributes and technologies to the proposed composition. IoT contributes the internet connection and remote management of mobile appliances, incorporated with a variety of wireless connections. Connections may be attached to home-related appliances such as air conditioning, lights, fans, and other devices. And so, it embeds software intelligence into home devices to provide ways to measure home conditions and monitor home appliances functionality. As QR stands for quick response, they can be read quickly by handsets. It works in the same way as a barcode at the supermarket. QR code makes work easy, and there will be no pressure of remembering IDs and passwords, combining softwares, hardwares, technologies, in order to generate the best product. In this project we explain the integration of IoT-based home automation. From the connectivity perspective, the added electrical appliances are connected to internet in the basic components of our project. R1. We connect the electrical appliance to the hardware. 2. Then the mobile application is created for easy control. 3. We create the QR code for each and every room. 4. Then the appliances are connected to internet. We describe the composition of an advanced smart home, incorporating these 4 components for building a practical advanced smart home automation. Finally, we identify open issues and future directions on the future of advanced smart home components and applications. 1.2 Related work. Smart devices remains the easiest and flexible way to a smart home. Smart things are nowadays most commonly used by smartphones, or smart handsets. There are many benefits of using smart technology for home automation, as it ensures convenience, sustainability, security, efficiency, save time, etc. A smart home is a home in which all the electrical appliances are connected to a control application. So they can either be switched on and switch off at any certain time, or any certain place. As home automation is more secure and saves a lot of time, even though many people does not use it because they can't afford it. The main objective of our project is to provide smart home automation which can be affordable by every individual, and by introducing QR codes it becomes more flexible and can be managed by anyone. By using two-way switching techniques, even old people can use transitional switching method. Given below is two-way switching technique. 2. Home automation. Devices. Requirements. 2.1 Hardware. 2.1.1 ESP32. ESP32 is a low-cost, low-power system on a chip microcontrollers with integrated Wi-Fi and dual-mode Bluetooth. It is capable of functioning reliability in industrial environments, with an operating temperature ranging from -40 degrees Celsius to +125 degrees C. It acts as an intriguing solution for IoT. The ESP32 peripherals include 0.18 Analog to Digital Converter, ADC, channels. 0.3 SPI interfaces. 0.3 UART interfaces. .2 I2C interfaces. 0.16 PWM output channels. 0.2 digital to analog converters, DAC. 0.2 I2S interfaces. 0.10 capacitive sensing GPIOs. 2.1.2 ESP8266. ESP8266 is a low-cost Wi-Fi microchip with a full TCP/IP stack and microcontroller capability. This chip first came to attention of Western makers with ESP01 module made by a third-party manufacturer AI Thinker. It is capable of functioning consistently in industrial environments due to its wide operating temperature range. The ESP8266 peripherals include 0.17 GPIOs. SPI. I2C, implemented on software. I2S interfaces with DMA. UART. 0.10-bit ADC. 2.1.3 electrical relay. A relay is an electrically operated switch. It consists of a set of input terminals for a single or multiple control signals and a set of operating contact terminals. Switch may have any no of contacts in multiple contact forms. The electronic relay is a type of an electronic switch that opens or closes the circuit contacts using electronic component without any mechanical operation. In this relay, the current carrier pilot relaying scheme is used for the protection of the transmission line. The electronic relay has several advantages likes. They require low maintenance. The relay has fast response time. They decrease the burden on the instrument transformer. Disadvantages of electronic relay. The high tension supply is required for their operation. The power consumption in the electronic relay is very high. The relay has the short lifespan. The electronic relay is practically not used in the power system. 2.2 Software. 2.2.1 Java. In our project, we are using Java as our backend process. Java is a general-purpose programming language class-based, object-oriented and designed to have as few implementation dependencies as possible. This language produces software for multiple platforms. Types of applications that run on Java. Desktop GUI applications. Mobile applications. Embedded systems. Web applications. Web servers and application servers. Enterprise applications. Scientific applications. 2.2.2 XML. XML is used as front-end process in our project. XML is extensible markup language that defines a set of rules for encoding documents in a format both human-readable and machine-readable. It is designed to store and transport data. It is designed to be self-descriptive. By using XML, web agents, and robots, programs that automate web searches or other tasks, are more efficient and produce more useful results. XML provides a standard method to access information, making it easier for applications and devices of all kinds to use, store, transmit, and display data. 2.2.3 Android Studio. Android Studio is official integrated development environment for Google's Android operating system, built on JetBrains IntelliJ IDEA software and designed specifically for Android development. It offers tools custom tailored for Android developers including rich code editing, debugging, testing, and profiling tools. It is purpose-built for Android to accelerate your development and help you build the highest quality apps for every Android device. It offers tools custom tailored for Android developers, including rich code editing, debugging, testing, and profiling tools. 3. Proposed system. App is a way to interface between user and devices. App scans QR code and save connection of setting into phone. App connects the device via local station. User is physically present near the devices. If user is not near the devices, it moves to cloud to connect to devices, and the devices will always be connected to cloud via local routes. Block diagram of smart home automation. Main board consists of ESP microcontroller, relay drivers, 5V supply, and relay boards. ESP checks for any update being sent via cloud, or local station and act accordingly. If user sends a signal to switch any appliances, the ESP saves the data and set, or reset the relay accordingly and then update this data to user and cloud. The app saves the acknowledged data sent from devices. Relay driver is logic shifter since ESP cannot drive relay directly and has a logic high of 3.3V and relay needs logic high of 12V. We use a buffer logic shifter whenever ESP sets a relay. It creates a magnetic field in the coil inside it. The input string connects to output terminal, similar to a switch we use whenever we apply physical press on a traditional switch. It connects therwo terminals, and current flows through the input to output and appliances turns on. Currently we are using a local host as our cloud. 4. Working Principle 4.1 Use Case Diagram 4.1.1 General Definition. A use case diagram at its simplest is a representation of a user's interaction with the system that shows the relationship between the user and the different use cases in which the user is involved. Use case diagrams consists of actors, use cases, and their relationships. The diagram is used to model the system/subsystem of an application. A single use case diagram captures a particular functionality of a system. Hence, to model the entire system, a number of use case diagrams are used. 4.1.2 Advantages. Use case help to capture the functional requirements of a system. Use cases are traceable. Use cases can serve as the basis for the estimating, scheduling, and validating effort. Use case can evolve at each iteration from a method of capturing requirements, to development guidelines to programmers, to a test case and finally into user documentation. Use case alternative paths capture additional behavior that can improve system robustness. Use cases have proved to be easily understandable by business users, and so have proven an excellent bridge between software developers and industers. 4.1.3 Design. Our home automation system has the following use cases. I. QR code. 2. SSID. 3. Login. 4. Add devices. V. Remove devices. The actors involved in the system are I. User. 2. Hardware. By using include relationship we can log in the application and control it globally, or by Wi-Fi, or Bluetooth. 4.2 Class diagram. 4.2.1 General definition. A class diagram in the Unified Modeling Language, UML, is a type of static structure diagram that describes the structure of a system by showing the system's classes, their attributes, operations, or methods, and the relationships among objects. An attribute is named property of a class which describes the object being modeled. In the class diagram, this component is placed just below the name compartment. A derived attribute is computed from other attributes. 4.2.2 Advantages. Class diagrams give you a sense of orientation. They provide detailed insight into the structure of your systems. At the same time they offer a quick overview of synergy happening among the different system elements as well as their properties and relationships. 4.2.3 Design. The home automation system makes use of following classes. I. User involves attributes such as name SSID and operations like turn on app and turn off app. 2. Room involves attributes such as QR code and SSID and operation turn on light and turn off light. 3. Network involves attributes like Bluetooth, Wi-Fi, and globally. 4. Electronic devices involves attributes ID and operations on and off. Association relationship is given between users and room and also network user and dependency is given between room and V. Electronic devices. 4.3 Sequence diagram. 4.3.1 General definition. A sequence diagram simply depicts interaction between objects in a sequential order, i.e. the order in which these interactions take place. We can also use the terms event diagrams or event scenarios to refer to a sequence diagram. Sequence diagrams describe how and in what order the objects in a system function. In a UML sequence diagram, lifeline, execution specification, message, combined fragment, interaction use, state invariant, continuation, destruction occurrence. Major elements of the sequence diagram are shown on the picture below. 4.3.2 Advantages. Sequence diagrams are used to represent message flow from one object to another object. Sequence diagrams are easier to maintain. Sequence diagrams are easier to generate. Sequence diagrams can be easily updated according to the changes within a system. 4.3.3 Design. It represents sequence and interaction of a given use case. This can show the most of information about the system. It shows the events which include signals inputs, decisions, interrupts and actions to, or, from users, or, external devices. A sequence diagram showing smart home automation system which involves the following objects. I. User. 2. Appliances. 3. Network. 4. Database. 6. Advantages. All electronic devices can be controlled and monitored from one place as QR code is a one-time process and can be accessed by anyone easily. Home security can be improved using smart home automation. QR code is more flexible for scanning than compared to other technologies. Encoding of all types of data like numeric, alphabetic, special, and binary is not required as it can scan directly. Maintenance of the software is easier than compared to other softwares as smart home automation is for new generation and old generation people would find it difficult to connect the apps/QR code/phones. We have implemented two-way switching technique which helps the old generation to use the traditional method of operation and by time they will also start using the app method for connecting. 7. Result. Following are the screenshots of our project. 8. Conclusion. This paper presents the new circuit topology for monitoring and controlling home electrical devices by using the flexible home-based Android smartphone at a reasonable price and implemented by using ESP as well as using Android app for system control configuration. The proposed new circuit topology is used in a quiet-based web services in an interoperable application layer for communication between the remote user and the home device. All Android-based smartphone, the Wi-Fi connection is the support built. The home access device to control can use the phone, Wi-Fi, 3G, or 4G to access the web page on hosting server using Android app.